Thanks for joining me today. Uh, just wanted to bring this up. It's been talked about, it was talked about extensively before Artemis II launched. I'm just afraid that there are going to be trolls out there in social media land who are going to try to bring this back up. And just want to just have a quick talk about it. Is the Artemis II heat shield safe? How NASA is balancing risk with exploration, so to speak. So we know that the Artemis II mission marks a very significant time historically. It's the first time in over 50 years that humans have traveled toward the moon and around it and come back. Well, the mission is inherently dangerous. There's always danger involved when you go into space, right? NASA's approach isn't about achieving absolute safety. I would say it's about meticulously managing the risk that goes with returning. Here you can see a artist graphic of Orion entering the Earth's atmosphere as the heat shield abates. So anyway, we're going to have that in a couple days, right? Well, if you know, Artemis 1, when it came back from its journey, sorry, still getting over bronchitis, it revealed unexpected charring on the heat shield, and engineers determined the cause was a gas pressure buildup. Okay, and you can see that on here that there was a lot of scarring, there was a lot of charring on the heat shield itself. When you actually look at the heat shield, and these images have been out for a while, this is from the NASA report, that you can see that the tiles were actually damaged. So after reviewing the tiles, and they are going to replace them for Artemis 3, but because Artemis 2 was already put together and the heat shield was already installed, NASA engineers came up with another solution. Okay, they decided that they call it the trajectory pivot, that steeper is safer. The primary fix for Artemis 2 is to modify the re-entry path. On Artemis 1, the skip re-entry, bouncing off the atmosphere like a stone on water, caused a heating-cooling cycle. This trapped gases inside the avocat material, which is used for the heat shield, building pressure until chunks cracked off, which you can see here. The solution, Artemis 2, is going to use a steeper direct re-entry. While this creates higher peak temperatures, it shortens the total time the shield spends in the danger zone. This allows the material to ablate, burn off more predictably without trapping gas and causing the cracking. Okay, there was a lot of speculation about this, whether this was going to work or not. But there's been former NASA astronauts and several engineers outside. NASA went outside and had it reviewed, and they all agree totally safe to do this. NASA engineers conducted a damage tolerance evaluation also to answer this terrifying question: what if the heat shield fails anyway, even with the steeper incline? They tested the composite-based material underneath the avocat blocks by blasting it with high energy up to 10 minutes, longer than the real re-entry. What did they find? The data showed that even the large chunks of the shield were stripped away. The Orion structure would remain solid and watertight, keeping the crew safe inside, even in a worst-case failure scenario. So working with researchers at the University of Kentucky, like I mentioned, NASA developed new ways to measure the breathability of the heat shield. New devices were built to measure exactly how gases move through the microscopic pores of the material, and advanced imaging allowed the engineers to see how the avocat responds under stress, ensuring that the modified flight plan keeps the internal pressure below the cracking threshold. Before launch, like I mentioned, NASA opened its data to independent review teams and even dissenting voices, including some former astronauts, like I mentioned. These reviews concluded that while the mission carries the risk, the modified re-entry profile remained in the margin of safety required for crewed flight. The Orion capsule is built for mishaps. It features 6 days, and you've seen that in the testing when they were the day before they did their lunar flyby. They donned their suits because their suits could protect them for up to 6 days, providing a safe environment if the capsule were to be punctured and lose atmosphere. They have extra batteries, solar panels, and parachutes if needed. And then the free return trajectory, just like Apollo 13, the mission's path is designed to naturally pull the spacecraft back to Earth using lunar gravity, even if the main engine were to fail, which hasn't happened. NASA experts like Paul Sean Hill suggest that while spaceflight remains scary, there's always a risk with it. The rigor of modern flight readiness reviews makes the mission perhaps the safest lunar attempt in history, and we can fully expect that when they're done. Here's the Alcat heat shield for Artemis II. We can expect that when they come in, sure, there'll be some the temperatures are pretty high. I fully expect the astronauts to make it all the way down, and we'll be able to see them being rescued in the Pacific, and the capsule being told to a Navy ship to be pulled back to NASA so that they can review everything about it. Anyway, so if you hear doom and gloom that the heat shield's going to fail, the astronauts are going to die, don't believe it. NASA, as always, has found the problem. That's why they did Artemis 1, right? They've resolved the issues, and it's about as safe can be when you're talking about space flight. Thanks for joining me. I hope you found that interesting. And again, if you hear garbage in the next couple of days about that, don't believe it. Okay? Thanks. Have a great one.